Okay, I'm going to show you a second example of finding the distance between a point and a line. And so my example here looks like this. It says find the distance between point P, which has the point 4, 3, that's 4, 3, and line Q, which has points 0, -3, and 7, 4. Now to do this one here, I'm going to just make a quick sketch of this and what this looks like. So if I made a quick sketch, point P is going to be 1, 2, 3, 4, 1, 2, 3, right over here. There's point P. My other one here, 0, -3. Let's see here. 0 and -3. So that's going to be right over here. There's 0, -3. And 7 and 4. Something about there. Now, if I drew, here's my line here. Okay, so there I get a line. Here are these 2 points right there, those 2 points. And here's point P. And what I'm trying to find here is basically that little distance right there. It's a tiny distance, but this little distance from this point P all the way to that line. Okay, what I'm going to do to accomplish that is I'm going to make and continue this line like this. I'm going to call this line N, whereas this one was line Q. Okay, there's line Q. Here's line N with point P right here. We know point P already is 4, 3. So what we're after here is what is this intersection? Because if we knew that intersection right there, we can get the distance using the distance formula. That's my game plan here. Now in order to get that, first I have to find out what is the slope of this line. Okay, the slope of that line is going to be equal to, let's see, you're going to get 4 minus 3, which will be 4 plus 3, all over 7 minus 0, in which case you get 1. The slope of this line is 1. And the equation of this line, and again I'm calling it this line, line Q, will be equal to y minus, I'm going to pick this point here and say y plus 3 is equal to 1 times x minus 0. In other words, I'm going to get here y is equal to x minus 3. Okay, there's my one equation for line Q. How about for line N? Well, for line N, the slope of it should be equal to -1. That's the negative reciprocal of this. And so my equation is going to be y minus, in this case, 3. That's a point I know. This is going to be equal to, okay, y minus 3 is equal to -1 times x minus 4, the other point. And if I simplify this, I'm going to get y is equal to -x plus 4, or y is equal to, or sorry, there should be minus 3 there. And if I move the 3 over to the other side, -x plus 7. So I get these two equations. These two equations should have the same point at their intersection. So to solve that, I'm going to set these two equal. I'm going to do it on a separate sheet here. What this will look like, okay, if I take those two, is it's going to look like, well, if I set -x plus 7, that's going to be equal to x minus 3. Okay, these are going to be equal to each other. If I move some things around here, I'm going to get 2x is equal to 10, or x is equal to 5. Now I have x is equal to 5, so I know the x coordinate right here of this. In other words, I know it's 5, something. What's that something? I have to plug it back in. Now the question always comes up, do I plug it in this equation or this equation? It doesn't matter. It doesn't matter because, again, you're finding the intersection, which should have the same point. And so I'm going to plug it into this one here. And what I'm going to get is I'm going to get y is equal to, instead of x, I'll write 5 minus 3, and I get the point, or the y coordinate, 2. In other words, it's at the point 5, 2. So right here, just to illustrate it, that should be 5, 2. In other words, this little segment here that I'm trying to measure goes from 4, 3 to 5, 2. Now we use the distance formula with those two. And so the distance formula will equal the square root, and again, just to remind you, I'm going to be using 4, 3. Where does that come from? This other point here, 4, 3 and 5, 2. And so I get here the difference of the x's, which is going to be 5 minus 4, and I'm going to square it. Okay, 5 minus 4 squared. 5 minus 4 squared plus 2 3 squared. In which case I'm going to get, well, that's going to give me 1 squared plus negative 1 squared. And that ultimately gives me the root of 2. And there's my distance. That little segment right here would have a value of root 2. That's the length of that segment there.